Hello, Honors Algebra students. Mr. Lawrence here, and I'm going to do one quick problem, continued with vertical motion, and to show you why you can't just think you know stuff. You have to explore, you have to examine. Okay? So here is the problem. It says a ball is dropped from a height of 60 feet. When will it be 30 feet off the ground? When will it hit the ground? Okay, so let me draw my little picture. Alright, get my marker out here. Alright, so here we've got this, and we've got a person standing here, and they're holding a ball, right? And we know that this distance here is 60 feet, right? That's the distance to the ground. Okay, we also know the ball is going to fall straight down. Okay, they want to know when will the ball be at 30 feet. Not sure why that switched to black. Okay, so at 30 feet, which is halfway down, and then of course when will it hit the ground? So we're still going to use our formula, h equals negative 16 t squared plus or minus v sub o t plus s. And we know that the starting height is going to be 60. But we also know that the initial velocity is 0 because the ball is just being dropped. Okay, so what is that? What did I say? Plus 60. All right, and I want to find out when the ball is going to be 30 feet off the ground, so I'll substitute a 30 in there. Okay, and I'll subtract 30. And that's going to get me 0 equals negative 16 t squared plus 30. I'm going to go quadratic formula on this. I could do it on factoring, but it doesn't factor super pretty. So let me go ahead and just go with the quadratic formula. So finding the discriminant first, I need the b squared minus 4ac, right? So that's going to be 0 minus 4 times negative 16 times 30. Okay, 480, 960, and then 1920. I think that's correct. Let me just double check. I think it's going to be 1,920, but let me check. 4 times 16 times 30. Just make sure I don't have a silly mistake. There we go. Okay. So, I'm going to go with t equals the negative b plus or minus the square root of 1,920 all over negative 32. It's always come out to be negative 32, right? So, of course, I only need to worry about the negative one on this. So I'll go to my calculator. The two negatives are going to cancel out. But I'm going to go to my calculator, and I'm going to do the square root of 1920, and I'll divide that by 32. Why not negative 32? Because I canceled out the negatives. Okay, and so it's going to take about 1 and 3,600 seconds. Okay, so the time here is about 1 and 3,600 seconds, right? Now, it's traveled halfway. Some people might think that, oh, well, I'll just double that and I will get the answer here. Well, let's see if that works, okay? So here we want the starting height to be 0. Excuse me, the ending height to be 0 because it's on the ground. Negative 16 t squared plus 60, right? My discriminant has changed, and so just to speed the video up, at 30 should be a 60. And so my new discriminant is 3840. It's 3,840. So I'll take the square root of 3,840 and I'll divide it by 32. And again, I'm only using the negative of the square root, and so it cancels with the negative 32. So it's a positive answer. And there I get 1 in 94 hundredths, which is not double the time. Why not? Why not? Why isn't it double? Because, you know, conventional logic, just the average person on the street, well, yeah, it moves. Well, the thing is this, anything falling under gravity's power is speeding up as it falls until it hits something what that's called terminal velocity. That's not the speed at which it dies. That's as fast as it can go based on the air resistance. Given an infinite well, meaning a hole deep enough and no air resistance, whatever the object was that was falling would continue to accelerate and accelerate and accelerate forever, theoretically, of course. So I wanted to point that out to you. It travels 30 feet in, a little bit over 1 1/3 seconds, right? But the next 30 feet, it takes just about a little bit over half a second. Yeah. So you see it covered the same distance in a much faster time. So I just wanted to point that out to you, that as things fall, they continue to speed up. And again, in this Algebra 1 class, we are neglecting air resistance, okay? When you get up into some physics classes or higher level math, then you'll start to learn how to do the calculations where those are involved. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.